Our topic is oxidation and oxygenation of hemoglobin and myoglobin. And first of all, we'll learn about hematin. Basically, as we know, in a heme group, the central atom, which is iron, is attached to four nitrogen atoms of the porphyrin ring. The fifth position is occupied by a protein chain, and a molecule of oxygen is attached at the sixth position. Generally, in this configuration, the iron atom is not oxidized, but when the protective protein chain is removed, the heme group becomes vulnerable to get oxidized, and hence the oxygen molecule oxidizes the iron atom and thus forms a mu oxidimer containing two iron ions and one oxygen atom, and this dimer is ultimately known as hematin. But this hematin is of not any use in human body because it cannot act as an oxygen carrier or binder, and hence it is considered as unproductive oxidative dimerization of iron porphyrin, and it is considered a fatal flaw for the biological functioning of hemoglobin. But this is not the case because the iron atom is protected due to the presence of hydrophobic protein chain around the iron atom and blocks the approach of larger molecules to come near the iron atom. And thus the oxidation of iron atom is prevented. But under certain controlled conditions, the oxidation can be carried out, and this iron 3 ion is responsible for the brown color of old meat and dried blood. Now we will see what is deoxymyoglobin. It is a generally 5 coordinate high spin complex with four of the coordination positions occupied by porphyrin nitrogen atoms. And again, as we know, it is basically a heme group, and the fifth position is again a nitrogen atom of an imidazole ligand of a histidine residue, which joins the heme to the protein chain. And in when the oxygen is not there, that is the sixth position is vacant, the ligand field is weak, so the complex is high spin complex, and it is paramagnetic in nature. Important things I have already underlined. And in the high spin, the iron atom has a larger radius than in the low spin complex, and hence the iron atom lies above the plane of the lies lies above the plane of the porphyrin ring, and the estimated difference bond distance is generally 218 picometer, and hence it forms a square pyramidal arrangement. Whereas when the iron becomes coplanar, it is only when the oxygen gets attached at the sixth position. It is because when the oxygen gets attached to the iron atom, it becomes a strong ligand field and giving a low spin complex, and hence the pairing effect is much more stronger than ever before, and it becomes a diamagnetic, and hence the bond system bond length also is 200 picometer, and hence it changes its shape from square pyramidal to octahedral. This is a square pyramidal shape when oxygen is not attached, and this one is the octahedral state when the oxygen gets attached, and hence as a result the iron falls into the plane of the porphyrin rings. And now we will learn about cooperativity, and this is a process which happens. It happens generally because when iron falls into the plane, it transmits a lot of strain to the protein chain attached to it, and when the protein chains get that thrust, they pass on it to the other sides of the hemoglobin, and hence and due to it, the other heme groups also become more exposed to the binding of oxygen molecule, and hence the other oxygen molecules get easily attached, and the equilibrium constant also increases from the first to the fourth, and the fourth constant being many times larger than the first one. Thank you.